Hi, this is Orange. It's my sorry. It's my pleasure to become a speaker at OrangeCon, and you know how this means a lot to me. Yes. So today I will present the confusion attack, and let's get started with today's presentation. First, I want to ask, is there anyone here who hasn't heard of the Apache HTTP server before? If so, please raise your hand. Okay, well, I believe I can skip the introduction. And I want to ask an additional question. How many people here are under 30 years old? Wow, there are so many young generations. Okay, Apache is an open source project that's nearly 30 years old. So I guess it might be older than some of you here. And because it has existed since the early days of the internet, it has accumulated a lot of technical debt. And another key point is that Apache enables CGI by default, which greatly increases the potential attack surface. And lastly, Apache is the only web server that can perfectly integrate with PHP. Since Apache and PHP were born almost in the same year, Apache was the first choice to use PHP in the early days. Apache also made several customizations for PHP, which led to several ways to configure PHP. For example, just for the fast CGI protocol, there are over 6 different modules to choose from. Especially each module has different directives. All of these make it complex to set up a PHP environment. And furthermore, some directives not only look very similar, but also have identical usage and effects, which can cause confusion easily. If a website admin didn't understand the intention behind each directive, it's easy to make mistakes and create security risks. For example, when the website admin wants to set up a PHP on his server, he might come across 2 common directives, add handler and add type. And which one do you think is correct? Actually, both are correct. Both methods can properly get the PHP running. So this means both configurations are all good? Firstly, being correct does not mean being secure. And under certain conditions, add type has been proven to be vulnerable, that allowing attackers to disclose the PHP source code remotely. And we will discuss the reason later. And the last thing I want to mention about Apache, and I believe is also the most important one, is from my years working in offensive security, I have observed that websites who use Apache tend to have more massive environments. Also, I can't think of any reason to use Apache other than for CGI. In practice, many servers are still running Apache and hosting a lot of third-party web services like Tomcat or Nginx locally. Also, they tend to use rewrite rule to organize the request, and usually the file system on the server is also a mess, with a lot of strange files sitting under the web root. So today our talk's mission is to break this type of the Apache HTTP server. You will learn how to identify such vulnerable servers and break them just like a piece of cake today. Okay, before we dive into the topic, let me introduce myself first. And you will know, you have already know I'm Orange. And currently I'm the principal security researcher at DevCore. I have spoken at several top hacking conferences, and my research has got numerous honors, such as the top 10 web hacking technique, Pong-to-Wong champion, and Pounding Award. So why we focus on Apache? At the beginning of this year, I started to explore some open source projects with widespread internet impacts, such as the Apache and the Nginx. I have even delved into some RFCs to deepen my understanding. And upon a close review of the Apache source code, I smell something bad in its coding style. Primarily, Apache relied on hundreds of small modules working together to handle a client's HTTP request. The source code includes 136 modules, and about half of them are either enabled by default or commonly used by website admins. And what's even more surprising is that these modules also share and maintain a very large structure while working together. The slide shows what the structure looks like, including all the elements involved in handling an HTTP request. In Apache, all modules relied on this massive structure for synchronization, communication, and even data exchange. And step into the internal, an HTTP request will pass through several phases, and the modules act like players in the game of the catch, passing the structure from one to another. And when on a module's turn, it focuses on completing its own task. And once done, it passes the structure to the next. This type of collaboration is not new from a software engineering's perspective. Each module simply focuses on its own tasks. And as long as everyone finishes their work, then the client can enjoy the service provided by Apache. And this approach might work well with a few modules. However, since any module can modify any value in this structure, when there are over 100 modules today, without any good standard or guidelines, can they still work together? Thus, our research was born. So our research focused on the relationships and interactions between these modules. Each module might be implemented by different people and subjected to years of iterations and code refactors. Do they really still know what they are doing? Even if they understand what they are doing, what about the implementation detail of others? They need to collaborate together. And however, if a module accidentally modifies a structure field, it's considered unimportant, but it's crucial for another module. It could affect the later's decisions. And furthermore, if there's any misunderstanding between any field within this large structure, it can create security risks as well. So from this starting point, we have developed 3 different types of attacks. As all of them are more or less related to the misuse of the structure. We have named this attack service confusion attack. And the following are the attacks we have developed. As this is a completely new attack service, the first person to delve into, of course, can find the most bug easily. So these confusion attacks made me the person who currently holding the most vulnerability from the Apache HTTP server. Additionally, because these vulnerabilities are based on legacy architectural issues, so most of the patches are not backward compatible. So updating Apache to the latest version might break old configurations. Therefore, for many production servers, simply applying the update to the latest version is not a good idea. Okay, let's dive into our main topic. First, I would like to discuss the attack called Filename confusion. This attack occurs when different modules handle the file name using different standards. Literally, the field file name should represent the file system path. But however, in Apache, some modules treat it as a URL. If we think a HTTP context, some modules consider the field as a file system, but some other are not. The inconsistency between these modules will create vulnerabilities. The first module consider the file name as a URL is rewrite module. This module allows website admin to redirect a request to any file or URL. I believe this is by design to enhance user experience. However, this convenience feature also introduced certain issues. For example, the rewrite module will treat the substitution result as a URL in all cases. For example, if the website admin sets the following rule to target the username right after the path/user to open the corresponding profile in the file system. So when you access the /user/orange, the module will open and output the file content of /var user orange profile YAML. However, what if you add one more question mark today? %3f is the URL encoded format for the question mark. During the name translation phase, the rewrite module will first process the rule and generate the corresponding destination target, just like this path. After the generation, even if the destination is a file system path, the rewrite module will treat all the result as a URL and separate the query part by the question mark. So there's a path truncation here. And this is our first primitive. You can use a question mark to truncate the path and to access unintended files. For here, we use this truncation to access the secret, which is normally inaccessible. Also, it might seem a minor issue for now. Please remember it because it will used heavily in our later attacks. Okay. Next, who else consider the file name as a URL? The proxy module too. At first glance, this seems makes sense because the purpose of the proxy is to redirect the request to other URLs. So when we consider this behavior on its own, it doesn't appear to be a problem. However, if your server relied on the file-based access control, it can be risky. For example, this is a common password protected configuration using the file directive to prevent unauthorized users from accessing admin.php. This type of authentication can be bypassed by default when the target is running under the PHP FPN. Imagine when you visit a URL like this today, admin.php, %3f, and oo.php. First, during the HTTP lifecycle of the access control phase, the authentication module will compare your requested file name with the protected file admin.php. At this point, your file name is admin.php :oo.php, which is totally different. So at this time, Apache didn't think you need authentication. However, to support various protocols like HTTP or FTP, the proxy module will rewrite the file name into the following URL and sends it to the backend PHP service. Since the backend received the file name in a string format, the PHP also implements some workarounds to adapt this behavior. PHP normalizes this unusual file name first and spread it by the question mark to get the original file name for execution. So the original authentication required admin can be bypassed with just a single question mark. Of course, it's not just admin.php. There are more risky configurations can be found on GitHub, such as the only local accessible PHP info and miner, which is blocked by default. Through the inconsistency between the authentication module and proxy module, all of this can be bypassed by just a single question mark. Okay, this is our first confusion attack. And the next attack we are diving into is the confusion based on the document root. Let's consider this common Apache rewrite rule for a moment. When you visit the URL /html/about, what file do you think Apache will actually open? Is it about.html under the root folder, or the file from the document root at /var/www and /html? Which one do you think the Apache will open? If you think Apache will open the /about.html, please raise your hand. And if you think the Apache will open the button one, please raise your hand. Oh, more people think we'll access the button one. Okay, actually, Apache access both. Magic, right? Yeah, this is also our second confusion. For any given rewrite rule, Apache always tries to open both the past version with and without the document root. This allows us to intentionally access the files outside the web root, especially the root directory. You might be wondering, hey, does this mean we can access the /etc/possibility? The answer is yes, but not entirely. Technically, the server indeed accesses the password file, but the Apache HTTP server's built-in access control blocks our access. You can see the default configuration is denied all. However, the built-in access control by default allows the access to the folder /user/share. And thanks for this configuration, we now have a limited arbitrary file access on Apache HTTP server. For example, we can access the documentations on the /user/share to learn how to use SSH. However, from the real-world case, such as the rule in the slide, the extension like .html is still the restrictions that keep us from being truly free. So you might ask, can we access the file outside the HTML extension? I'm not sure if you remember the primitive of the press truncation from the Filename confusion earlier. We can combine them together using a question mark to truncate the extension. So theoretically, as long as the target prefix of a rewrite rule is controllable, we can access nearly the entire /user/share. This is a blast. Even the tutorial from the official Apache website has problematic examples. And okay, we now know the root cause. And what can we do with these attacks? First, we can disclose arbitrary server-side source code. Since Apache decides whether to execute the script or not based on the current virtual host or directory. So access the full path through a virtual host that doesn't support PHP allows us to easily expose its source code. And since we have broken the trust of the only accessing the DocumentRoot, the entire /user/share has now become our playground. So the next step is to find out what files under this folder we can exploit. We can leverage existing tutorial examples, unit tests, or even packages from programming language to become our gadgets. So the first gadget we are going to demonstrate is leveraging the library Office, which is installed on Ubuntu desktop by default. We can leverage the language switch feature in the help files to achieve accesses. Or we can disclose sensitive information. For example, if you install the WebSocket D, the daemon will by default include an example PHP script called dumpenv.php. You can directly access the file to leak sensitive environment variables. And additionally, if the target has the service like Nginx or Dratty installed, the default web roots are also located under the /user/share. So you can download sensitive application data such as the web.xml by a simple rewrite rule. Here we demonstrate how to execute the PHP info to leak sensitive information by devical package. Even some PHP or front-end packages, their tutorials or debug console can be leveraged as well, such as the jQuery, MagPie, or the JP Graph. For example, we use the tutorial from the jQuery feed to read arbitrary file content. Okay, by now, you can see the possibilities of this primitive. You can see the possibility of this primitive are huge. Local gadgets are endless, and all that remains is to find more powerful gadgets or more universal gadgets. But you might be curious and asking about, can we jump out of the /user/share? Of course we can. And that brings out our third primitive. To jailbreak from the /user/share. Apache, by default, follows the symbolic links. So we can leverage this feature to jailbreak from USR share. So any package that has a symbolic link in its installation folder can become a stepping stone to access more gadgets for further exploitations. Here are some useful symbolic links we have discovered so far. You can read the cacti logs on the /var/log, read the server configuration on the /etc, and even access the readme files. And here we will demonstrate a remote code execution trained on readme through a double hop jump. There is an instance folder that can jump to /var/lib on the readme. And within that folder, the config directory can also jump to the /etc/readme, which contains a lot of readme's database configuration and its secret key. So by using an insecure rewrite rule, we can access the secret key used by readme through a double hop jump. And since readme is a Ruby on Rails application, the content of the secret key is actually the key for signing and encrypting. So the next step should be obvious. Embedding a malicious object into the cookies, signing and encrypting with the known key, and then get code execution through the server-side deserialization. Okay, that's our second confusion attack. The last attack I'm going to introduce is the confusion based on the handler. This is also an attack leverage a piece of technical debt in Apache server's legacy architecture. Back to our initial question. Why can both directives, one for adding a handler and one for adding a type, can run PHP properly? This is actually due to a legacy conversion in Apache. Or you could say it's part of its technical debt. Before Apache enters the main handler for processing the HTTP, if the handler field is empty, Apache will take the value in the field of content type as its handler. So our third handler confusion is playing around this behavior. In Apache, sometimes the content type can be transformed into the handler. Yes, can be transformed into the handler. So what can we do? Let's show you something fun first. Imagine that your server is running PHP using the add type directive, and you access the file config.php. Since the file extension is .php, during the phase type checker, the Apache will assign the corresponding value to the content type field based on your configuration. And the PHP will know, it's his responsibility to handle this request. The normal process works well. However, before entering the main handler phase, the legacy conversion we mentioned earlier will convert the content type into the handler. So this explains why both add type and add handler are effective. But what if any module accidentally overrides the content type before reaching the run handler phase? For example, you can triggering a filter error in the mode security module. If the mode security find an error, the module will think, it has made some mistakes and want to send out some error message. And since the error message is in HTML, it sets the current content type to HTML2. So the config, which was supposed to be executed as PHP, is treated as a plain HTML now, exposing all the sensitive content to outside. So this is also our first primitive for handler confusion. By abusing the old handler confusion mechanism, we can disclose any PHP source code by overriding the content type. Theoretically, all directives based on content type are affected by this issue. But if we think deeper, the nature of this issue is actually there are no clear guidelines for the use of the field content type. It can be set by a config directive during the request or use the content type header in the server response. Apache cannot distinguish which one it is while using the field. So ideally, if we can control the content type, we can invoke arbitrary handler. So can we really do that? It's very promising. However, there's still one last piece of the puzzle. The situation is not as simple as it seems. And in practice, all the code paths that can modify the content type are old after the legacy transformation. So even we can modify the content type through the server response, it turns out to be useless. So what can we do next? don't worry, we turn to the RFC to save us. The RFC 3875 is the specification for CGI. And the section 6.2.2 introduced the local redirect response. The local redirect response works like this. If the CGI returns the status of 200 and include a location header, instead of handling it as a client-side redirect by the browser, the CGI treats this location target as a server-side redirect. And the Apache implementation of this server-side redirect will open a new HTTP lifecycle and copying the original field of the content type to this new structure. So for example, if you can control the response header through CGI, and that means you can control the content type field. And when the Apache sees, oh, the status is 200, it performs the server-side redirect and started a new round of HTTP processing. And in this new round, the content type header returned by the earlier CGI is pressed into the structure. And after the legacy content type handler conversion, the content type we provided becomes the handler and allowed us to invoke arbitrary handler. So this is our second primitive. It's the ability to code arbitrary handler. And basically, the entire CGI family follows this feature. So including but not limited to the WSGI, fast CGI, or UWSGI. As for how to trigger this server-side redirect, here we provide two scenarios. One is the CRF injection, and the other is the SSRF that can fully control the response header. And we will use the CRF injection as the example below. In the normal case, this type of vulnerability will be treated as XSS because you can inject HTML into the content. However, if you override the content type with a name called the server status, then you can lack sensitive information that should only be accessible from the local host. You can also easily transform an image into your PHP backdoor by setting the content type to PHP. You can even achieve SSRF through the proxy module. And this SSRF allows you to control request headers and can read all the response. And super thanks to the convenience brought by the proxy module. The most awesome things about this SSRF is that it can also access the local Unix domain sockets. So lastly, let's demonstrate how to turn this SSRF into a RCE. Here we used a common trick in CTF. The official PHP Docker image by default comes with peer, a PHP extension manager. And the peer CMD is the entry point used to manage the package. So we can leverage this SSRF to execute the peer CMD to do further exploitations. For example, we exploit a command injection in the run test command. And we can get a reverse shell easily to execute arbitrary commands. So please do not report the header-based CLR of injection as a XSS again. It's really a waste. Because today, you have learned a new way to exploit. This type of bug has the potential to become RCE. Here, my presentation is almost coming to the end. And before closing, I want to say, maintaining open source is really challenging, especially keeping a project for 30 years. You have to make it convenient for end users and compatible with all versions. The entire development process is built upon a pile of legacy code and technical debt. So if there are any Apache developers in the audience today, I want to say thank you for all of your hard work. And before we finish, let's have a few takeaways. So first, the question mark is a powerful tool that allows you to truncate arbitrary passes. You can bypass access control and authentication easily by playing the inconsistency between the modules. And next, the rewrite rule contains the hidden trap that allows access the system root. And lastly, by controlling the response header, you can invoke arbitrary internal handler through the legacy conversion mechanism. Also, there are some future works. For example, different distribution have different configurations. So exploring such as the FreeBSD or even on-premise applications could reveal more allowed by default ACL and reveal more local gadgets and symbolic links. And finally, due to the maybe time constraint, I'm not able to introduce some real-world cases. But you can imagine there must be countless rewrite rules to figure out. There are a lot of ACLs to be bypassed and a lot of hidden CGIs out there. Applying all the techniques we discussed today to bug bounty hunting is now your mission. Okay, this is the end of my presentation. If you have any questions, here's my contact information. And thank you for being here again. Thanks.